guys, welcome to your review on series. We're going to start with this do now. What's the difference between these two questions? Given the sequence 2, 3, 4.5, 6.75, find the eighth term. And given the sequence 2, 3, 4.5, 6.75, find the sum of the first 8 terms. So of course the difference is that this question on the left is just asking you to find the eighth term, which means that we're going back to our sequence formulas. Whereas given the sequence we want to find the sum of the eighth terms, we're not just looking for a single term. We're looking to find the first term plus the second term plus the third term plus the fourth term all the way up to the eighth. So that's sequences versus our series formula. So let's just find the eighth term first. This is a geometric sequence formula. It is going up by a multiple, but it's got decimals. It's not the easiest multiple to find just by looking. So if I'm saying, all right, 2 times what equals 3, the easiest thing for me to do is going to be to work backwards and say what is 3 divided by 2. 3 divided by 2 is 1.5, which means that 2 times 1.5 gives me 3. And if I want to be sure that that's my ratio the whole way through, I should probably check a couple more terms and make sure that that keeps working. So I can say 4, what a smart word, 4.5 divided by 3 also gives me 1.5, which means 3 times 1.5 is giving me 4.5. So that seems like it's my ratio. I've got that common ratio of 1.5. So R equals 1.5, and then if I'm plugging into the rest of this sequence formula up here, A sub 1 is my first term, which in this case is 2. And then A sub n is the term we're looking for. And that's coming out of the question. The question told me to find the eighth term, so my n is going to equal 8. So A sub 8 equals A sub 1, which is 2, times R, which is 1.5, to the n, which is 8 minus 1. So I've got 2 times 1.5 to the 8 minus 1 power. And of course, 8 minus 1 is 7. So I have 2 times 1.5 to the 7th power. And if I pop that into a calculator, I'm going to get 34.17. And that's rounding. So that is my eighth term. But it's not the sum of all 8 terms. It's just the eighth term. If we want to find the sum of the first 8 terms, for geometric series, we can plug in to this geometric series formula, which is given to you on the Regents exam. And it's a nice one because all of the variables in there mean the same thing that they mean in the sequence formulas that you guys have got to be pretty familiar with. So A sub 1 is still going to equal 2, because it's the same sequence, so I don't know if you guys noticed. And then R is still going to be 1.5. And since we're finding the sum of the first 8 terms, our n is still going to be 8. But now we're doing the sum of the first 8 terms. So S sub 8 is equal to the first term minus the first term times R, 1.5, to the n power, and n is 8. So I've got 2 minus 2 times 1.5 to the 8th. Keep in mind PEMDAS, you cannot multiply before you raise to the 8th power, so this is not going to be 2 times 1.5 is 3 to the 8th. And then on the bottom, we've got 1 minus R, so 1 minus 1.5. And to me, the thing that is trickiest, honestly, about series formulas is getting that into your calculator correctly. So 2 options we've got. You could put parentheses around the entire top and the entire bottom of your fraction so that your calculator doesn't get confused about PEMDAS. Or Or if that's something that's hard for you to keep track of, you can hit alpha, which is that green button, and then hit y equals, and then hit enter. And it will give you a fraction to fill in, and then you don't need to worry about parentheses. You can just put the top of this into the top of the fraction, and the bottom of it into the bottom of the fraction. So if you have a TI-84 with you, pause the video and give that a try to make sure you can do it. And if you have that correct, you should get out 98.52, and then that's rounded. But that is the sum of the first 8 terms. So it's adding up 2 plus 3 plus 4.5 plus 6.75 all the way up to this 34.17 that we found was the 8th term on its own. So that is the series formula. That's how we use it. You don't have to know this proof. I just wanted something fun on the board behind me while I briefly talk about the difference between the summation symbol, sigma, that you guys reviewed yesterday, and this series formula. Now, in some ways, I do think that sigma is a little bit easier. It's something that plugs into your calculator very directly. The downsides to sigma are that, one, you cannot use sigma without a calculator. Sigma is a notation that just means add up all of these terms, but if you don't have a calculator with sigma, it doesn't help you. Whereas the geometric series formula is something that if you needed to, you could do by hand. And then the other nice thing about the series formula is that if you can find the variables to fill in, if you can find your A1, if you can find your R, if you can find your N, you don't need to figure out the actual rule or the actual pattern by which your sequence is going up. All you need to know is those variables. Whereas for sigma, you have to have that rule that you fill in next to sigma explaining how your sequence is growing. So that's the advantage of the geometric series. We're not going to go through this proof because you don't need to know it, but it is kind of neat. So if you're bored at home in quarantine and feeling excited about math, it could be a fun thing to look up. All right, we've got a region problem here. So I'm going to read it out loud, and my first question for you is, what vocabulary in this question tells you that we're talking about a series problem, where we're adding up the terms rather than just a sequence problem where we're looking for a specific term? So I'm reading, you're looking for vocabulary. A 7-year lease for office space states that the annual rent is $85,000 for the first year and will increase by 6% each additional year of the lease. What will the total rent expense be for the entire 7-year lease? 1, $42,809.63. 2, I'm not going to read them. Multiple choice options, you guys can see. So the big important words in there are that we're seeing total rent expense for the entire 7 years, as opposed to how much will the rent be the 7th year. We're looking for the entire thing for all 7 years. There we go. So that means we need to plug into the series formula. We need to know our A1, we need to know our R, we need to know our N. Let's start with A1, A7, because that's pretty easy. What's our starting amount, our starting term? And they tell us that it's going to be 80. Why is that happening? Come on, smartboard. I complain about the smartboard all the time, but it's going to be worse when I have to start making these videos at home on my own computer. So our first year, it's $85,000. That's our initial amount for our starting year. So that's our A1. I should be writing this longer. I'm going to have space. Okay, and then N is pretty easy to find also, because we're looking for the entire 7-year lease. How many years is that going to be? 7. So we're adding up the first 7 years worth of rent. And then the tricky one here is R. And when we see the 6%, We know that that's our growth rate, and we know that, I mean, you should know, I hope, because we went over it, that in problems, we're going to write that 6% in decimal, so it is going to be that 0.06. But take a moment to think about that. If we took that $85,000 and we multiplied it by 0.06, we would not be getting an amount that went up by 6%, right? What we would be getting is what 6% of 85,000 is. And if I grab my calculator, I can say that's something like, I don't know what my calculator is. It's going to be something a lot smaller than 85,000, right? We know the numbers going up, not down, and we know that that's not going to work if we're multiplying by 0.06. What we're actually multiplying by is 1.06. Because we're taking the full 100% of the rent that we already were paying, that $85,000, and then we're going 6% further. So it's really 106% of the rent, which as a decimal is 1.06. So we're going to plug that into our series formula, which we have at the top of the slide, so I'm going to go down. So that's A sub 1, which is 85,000, minus A sub 1, times R, 1.06, to the n power, so to the 7th power, over 1 minus R, so 1 minus 1.06. And if you plug that into your calculator correctly, you are going to get that the answer is option 4, $713,476.20. Again, I would pause the video for a moment and make sure that you can get that into your calculator to get the correct answer out, because the most common mistake with these problems is not the setup, but the actual entering into your calculator. All right, once you've done that, go ahead and try this Regent problem on your own. Pause the video and give it a shot. And then once you have your answer, start the video going again, and I will give you the method and the solution. All right, I'm assuming all of you guys have paused and done the work. So the first term of a geometric sequence is 8, and the fourth term is 216. What is the sum of the first 12 terms of the corresponding series? So we want to find the sum of the first 12 terms. We know that it's a geometric sequence, so we can plug in the geometric series formula to do that. We know A sub 1 is 8, and we know that we're adding up the first 12 terms, so we know that n is 12. What's a little bit trickier here is R, because we don't know the middle two terms yet. We don't know A2 and we don't know A sub 3. So let's think for a moment about how to set that up. We know that there is some number, some ratio we're multiplying by that is eventually going to get us from 8 to 216. And what we're doing is we're multiplying times R to get to the second term. Then we're multiplying by R again to get to the third term. And then we're multiplying by R again to get to the fourth term, which is 216. So it's 8 times R times R times R equals 216. Or I could rewrite that as 8 times R cubed equals 216. So now I'm going to divide both sides of this by 8, because what I'm just going to do is solve this equation I've set up for R. So divide by 8, divide by 8, we get R cubed equals 27, and we can put the cube root into the calculator, or if you happen to know, the cube root of 27 is 3. So R is going to equal 3. 8 times 3 is 24. 24 times 3 is, I don't know, what is it? 24 times 3 is 60, 72. Yeah, 72 and 72 times 3 is 216. Sorry, probably probably should have had that math done though before I started this video. So we're going to ratio is 3. We can plug that in. And then we can now plug this whole thing into the geometric series formula. So we're going to say S sub 12 equals A1 minus A1 times R to the n power over 1 minus R. And if we put that into the calculator correctly, again, you're either hitting alpha y equals enter, or you're putting parentheses around the top and bottom of that fraction. You should get out 2,125,760, which is the answer choice 3, if we go all the way back up to the top. Alright friends, so that's our video series. Go ahead and do the series portion of your Delta Math to try and practice this. If you have any questions, please reach out over Google Classroom or Google Class, or sign up to have office hours with me, and we will discuss it in person over the phone. If you're sending me an email about a specific problem, please, if you can, include a screenshot of that problem, and if possible, of your work, so that I can see specifically what issues you are having. Have an amazing day. Get in touch. I miss you. Bye.